lecture number 11, Stoichiometry, part 1. So now we've taken these atoms, combined them to make molecules. Last time we talked about making these molecules in, or the time before, making molecules in sort of amounts that we can deal with in the moles and grams. The last lecture we talked about then taking these molecules and reacting them to form new things, taking reactants and forming products. So now let's combine those two things in the process we call stoichiometry. So this is the qualitative study of reactants and products in a chemical reaction. So we're looking at now, instead of just what is reacting or what is being produced, but how we can relate amounts to that. And we're going to relate that through what we call the mole method. So we're always going to work through this idea that in a balanced chemical equation, this equation gives us a relationship in moles. So we can talk about the moles of reactant giving us moles of product, or moles of one reactant reacting with a certain amount of moles of another reactant to form products. So all of this case, we're always going to relate in moles. So this is new. We've already worked here between this mass idea, going from the mass of a substance to its moles from the molar mass, or the number of moles to unit sort of entities or molecules or atoms. We've done that already. Now we're going to make this sort of bridge between those. So we're going to look at this moles of product to moles of reactant relationship. We're always going to work through that when we work with this stoichiometry. So it only always depends then on getting to that moles. If we have a mass of the reactant, then we're going to take the mass and convert to moles using the molar mass. Then we can go to the moles of product or moles of something else. Or more likely, we're going to take the mass of reactant, go to moles, and then go to moles of product, and then talk about the mass of product. So we're usually going to start with mass and end with mass. But every time we do one of these problems, we're going to go through this mole, what we're calling a mole-to-mole ratio. The moles of one substance, how is that related to the moles of another substance? And that's always based on this balanced molecular equation, or balanced chemical equation. So that's where we have to start. We have to write a balanced chemical equation relating reactants to products. Make sure that the formulas are correct, but also that reaction is balanced. And then we're going to convert whatever known quantities we have into moles. So like I said, we're always going to this moles. And then using these coefficients, the balanced chemical reactions, we're going to relate the number of moles of what we start with to the number of moles of what we'll have at the end. And then finally, we'll convert that moles into whatever desired unit we want. So it could be grams, it could be kilograms, it could be micrograms. Doesn't matter. At that point, it's still the same thing, going through that molar mass to desired product. So let's look at an example. Let's look at this reaction where we take iron oxide and react it with carbon monoxide to form iron and carbon dioxide. And let's calculate the number of grams of iron and the number of grams of carbon dioxide when 0.150 kilograms of iron oxide reacts. Right, so let's sort of map this out using that process. We have a balanced chemical reaction. Take a second, look at it, confirm that for yourselves. But then we're going to go from this mass that we have to moles of iron oxide, and then to moles of what we want. And I'm showing here just one of them. We're going to talk about the iron. Moles of iron, and then we want it at the end of the question, we want grams, so we have to convert to mass. So this is the process we're taking. Mass to moles, moles to moles, moles to mass. So if we start with what we have, the 0.150 kilograms of iron oxide, multiply that by the conversion to get to grams, because our molar mass is always in grams. So there's 1 times 10 to the third grams per 1 kilogram. Divide by the molar mass of iron oxide, 159.7 grams. Right, so now we have the number, at this point we have the number of moles of iron oxide that we have in that 0.150 kilograms. But we don't want iron oxide, we want information about the iron. So now we're going to do a mole-to-mole ratio. So from the balanced equation, for every one of those iron oxides that reacts, we're going to produce 2 moles of iron. So we have this 2-to-1 molar ratio. Again, we put the 1 mole of iron oxide on the bottom to cancel out that unit, giving us this 2 moles of iron on top. We want grams at the end, so we're going to have to multiply by its molar mass the 55.8 grams. Do the math, multiply everything on top, divide everything on bottom, and we'll get this 104.89 or 87, excuse me. Taking care of significant figures, which would be 2 in this, 3 in this case, we end up with 105 grams of iron. We could do something very similar for the carbon dioxide. We're going to start, it will be the same up until that molar ratio, and then now the molar ratio is going to be 1 mole of iron oxide to 3 moles of carbon dioxide. Have to then take into account the mass to get carbon dioxide. I'll let you do that one on your own, but you're going to follow the same process. So you can see now in this stoichiometry, we're sort of putting all of these pieces together. We're taking the atoms themselves, making ions. The ions are coming together to make molecules. Molecules are coming together to get balanced reactions. And then we're following that process through mathematically, through these amounts, using the dimensional analysis that we started with. So we're starting to see that all those things we've worked on the last 2 chapters are starting to build on each other, and now we'll see its usefulness in chemistry. One more example we can look at here with aluminum hydroxide with HCl, again giving us aluminum chloride and water. We can see now in this problem we want to calculate the grams of HCl that can react with 0.5 grams of aluminum hydroxide. So in this case, we're not interested so much in the products, but we want to know how much of another reactant we have. But we're still going to go through this mole-to-mole ratio because the balanced chemical equation, remember, gives us a relationship of moles. So if we figure out how many moles of aluminum hydroxide we have, we can then figure out how many moles of HCl we need to react with that, and then convert back to mass. So you can see it here, 0.5 grams of aluminum hydroxide times 1 over the molar mass, the 88.004, gives us moles. Get rid of the molar ratio, go from moles of aluminum hydroxide to moles of HCl, so we're multiplying by 3, and then we're going to convert back to grams to get the 36.58 grams. So 0.6121 grams of HCl is needed to react this 0.5 grams of aluminum hydroxide because of the molar ratio. So for now, we're going to take, again, work this dimensional analysis to figure out, convert from moles of one thing to moles of another through this balanced chemical equation. Okay. Next time we'll take this a little bit further and we'll do some more involved calculations where we might start with 2 things and figure out how much product we're going to get, and then we'll talk about some other properties along with that. Okay. Also, for next time, I said we'll be working in groups. Here are the groups we'll be working out until the next exam. Find your name, group number. I'll have this information again in class on Thursday. So, again, taking this from the balanced chemical equation, working it so that we convert from some amount of one to some amount of another species in that balanced chemical reaction.
Dad, I done did it.